All right, here we go. Second lesson for chapter 2. Remember, we are skipping 2.2, moving on into 2.3. So 2.3 is about something called conditional statements. For conditional statements, and you saw a lot of these in the last lesson, are if-then statements. So if is what we call the hypothesis. This is the start of the argument. So if is the given information. All right, so we call it the hypothesis. So if something is true, then we state the conclusion. Right, so the conclusion part of this always follows the word then. Right, and so if is like a signifying word to signal where the hypothesis is. That's our given information. The word then is your signal to signify the conclusion, right? The assumption or the conclusion that was made based on the given information. So that's what we have here. So when you have an if-then statement, first part of this, all they wanted you to do was identify the two parts. So what part is the hypothesis? What part is the conclusion? So if I said if angle X is congruent to angle R and angle R is congruent to angle S, then angle X is congruent to angle S. So this is the conclusion that was made based on this given information. Right, and so all they wanted you to do was underline what's what and identify them. So here's something that's super important. You need to hear me on this. The hypothesis does not include the word if. Right, if is a signal. Right, it's there to point to the hypothesis. Okay, but if they said underline the hypothesis, you would not underline the word if. Okay, it's there as a signal to point you to the hypothesis. So here was the hypothesis, and then the same thing is true with the word then and the conclusion. The word then is a signal, right? It's there to point you to the conclusion, but it's not part of the conclusion, right? It's just there as something to identify, hey, here's the conclusion, right? That's what it's there for. So anyway, let's move on to one more here. This is their example. So this one is good because it's not already written in if-then form. They want you to write it in if-then form, then identify the hypothesis and the conclusion. So they said, hey, you receive a free pizza with 12 coupons. So that's just a normal statement. Hey, you're going to get a free pizza with 12 coupons. So how could you rewrite that into an if-then statement? We need to separate out what part of that is the conditional part, like what is the setting, what has to be true, and then what's the result, right? What's the conclusion? So if you look at it this way, so we said, okay, so here it is in an if-then statement. So if you have 12 coupons, right? So that's the condition. So if you have 12 coupons, there's the condition. Then the result, the conclusion, is that you get a free pizza. Okay, and so you can see the way that it was written. That makes sense. If you try to flip it around, it shouldn't make sense. And so like if I would have said, if I wasn't sure and I flipped it around and I said, if you receive a free pizza, then you have 12 coupons, right? That's not only not always true, but that doesn't really state what this message is trying to get across. Okay, this message is trying to get across that, hey, if you got 12 coupons, we're going to give you a free pizza. If you flip it around, and if I said, well, if you get a free pizza, then you have 12 coupons, that wouldn't always be true, right? Because maybe I'm getting a free pizza because I know the person that works there. Instead of having 12 coupons, I just know the person that works there. So if you flip it around, it definitely would not always be true, right? But in this case, it would only make sense to say if you have 12 coupons, then you get a free pizza. So remember, the hypothesis is whatever follows the word if, does not include the word if. The conclusion is whatever follows the word then. So, and again, then is there as a signal. It's not part of the conclusion. It's there to tell you where the conclusion is. So we get a free pizza. That's the result. All right. So really easy when it's already in if-then form, because we already know that if is the word that signals where the conclusion, or sorry, the hypothesis is. So it is Saturday is what we call the hypothesis. The hypothesis is the part of the statement that is being given to you. Right? It's what you're told is the foundation of the statement. It's what we call the condition. Right? So here is the condition. It's Saturday. So what's the conclusion that you would make? You would say, well, then there's no school. So that's the conclusion that we would make. Remember, it does not include the word then. Then is there as a signal to tell us where the conclusion is. The tougher ones are the ones like this. Let me refocus. Are the ones like this, where you have to put it in if-then form, because these can be a little tough. So try to figure out what part is being told to you and what part is the result. What part is would you conclude about the given information? So if we said the sum of the measures of complementary angles is 90, so what part of that is the result or the conclusion, and what part of that is the condition that is being told to you? So I would say on this one, the condition that they're telling me is that I have complementary angles, and the result is that then they must add to 90 degrees, right? So I would say something like if angles are complementary. I'm going to abbreviate here. So if angles are complementary, then the conclusion or the result is that they add to 90 degrees. So then their sum is 90 degrees. So that's the way I would have seen it. If you tried to flip it around, would it still make sense? So if two angles add to 90 degrees, then they are complementary. That would still work. So you could potentially still word it that way too, and maybe be correct here. So you have to kind of play with that a little bit to see if you flip it around, would it still be true? This is the message they were trying to get across: is if angles are complementary, then their sum is 90 degrees. So I would have said, here's my hypothesis, and there's my conclusion. So collinear points on the same line. That's just the definition of collinear points. So think about what part of that is sort of the condition that they're giving you, and what part of that is the result or the conclusion. So I would have said the condition is that they're telling me I got collinear points, right? And so the conclusion I would make would be to say, well, then they have to be on the same line. So I would have said if points are collinear, then they're on the same line. So that's the way I would have definitely worded it. This is the condition that they're giving me, and then this is the result, is that they happen to be on the same line, right? That's the result of being collinear. So I would say the hypothesis is that the points are collinear, and the conclusion is that they lie on the same line. When they say determine the truth value of each conditional statement, all that means is determine whether it's true or false. So when they say determine the truth value, decide whether it's true or false. If it's true, you have to explain why it's true. And if it's false, give a counterexample. We did that in the last video. So piece of cake. So if today is Wednesday, then yesterday was Friday. So definitely I would say, hopefully you guys are saying false on that one. If today is Wednesday, then yesterday is Friday. Yesterday was Friday. So I think we would all agree that that was false. And so if it's false, we have to give a counterexample. So if today is Wednesday, then a counterexample would certainly be that yesterday could definitely have been Tuesday. So I'm not going to write all that, but that's what we would write. So yesterday could be Tuesday. That would be the counterexample. Number 5, if A is positive, so A is just a variable, like X. So if X or if A is positive, then 10A is greater than A. So if you take any positive number and multiply it by 10, would you get a bigger number, right? Or can you think of some kind of counterexample to that? So on that one, I would have said certainly that's true. There's no number that you can come up with, no positive number that you can come up with, where if you multiply it by 10, you get a smaller value, right? So this one we would say certainly true, and my explanation, So if you're ever asked in homework to explain your reasoning, make sure that you do that. I do check for that when I grade the homework. But if it's true, which it is in this case, my explanation would simply be that with A being a positive number, 10 of those, right, would have to be a bigger value. It have to be greater than A. And you can even put in a real number example for that, right? So if A is 5, then 10A, which would be 50, is greater than 5. Okay, and so let me jump over to the one last page here. So with all these conditional statements, so a conditional statement, remember, that's just an if-then statement. They do a lot of this with symbols and notation that you kind of got to get used to a little bit. So along with the vocab, we also have to get used to some symbols or some notation that they used. So for these ones, there's 3 different ways you could alter a conditional statement. The conditional statement is the original if-then statement. Okay, and so they're using the arrow to represent the phrase if-then. P represents the hypothesis, Q represents the conclusion. So when they say, if something, then something else, so P is the first part, Q is the second part, and the arrow represents the if-then phrase. So there's 3 things you can do to that. For one, you can just flip the order, right? If I turn it around, so let me put in some real phrases, because this makes a lot more sense when you put some real phrases in here. So if today is Saturday, then there's no school. So P would be the fact that it's Saturday. Q would be the conclusion that says there's no school. Okay, so, and they have their own example that you could use over here too. So if angles are vertical angles, so 2 angles are vertical, that's the P right there. The conclusion that they're congruent is the Q, right? That would be the conclusion. So if we flipped it around, so we're going to change the order. We're going to now say if Q, then P. So if, here's what it would look like if you flipped it around. Okay, so now they're going to say if 2 angles are congruent, then they are vertical angles. So they're flipping it around. We call that the converse. So the converse is when you flip the order. Okay, and this is the way you would write that as far as notation goes, right? So you're putting this guy first and this guy last. The inverse is when, there's a new vocab word in here. It's when you negate the 2 statements. Negating is like throwing in the word not, right? So if you go back to the original one here, that if 2 angles are vertical angles, then they are congruent. If we put in the word not in there, so, and you can read it right here, so if 2 angles are not vertical angles, then they are not congruent. So this little symbol, this little squiggly line, represents the word not, and we call that a negation. Okay, and so this one does not change the order, it simply puts in the word not, and we call that the inverse. The contrapositive is when you do both of these. Okay, and so if I flip the order and put in the word not, it looks like this. Right, and they call this the contrapositive, and you can read it over here. So now they're going to say if 2 angles are not congruent, then they are not vertical angles. So they switch the order from what it originally was, and they put in the nots. So if you look down here, I put in a little statement right here that I typed in that says the truth value of the conditional statement, whether it's true or false, always agrees with the contrapositive. So if the original conditional statement is true, the contrapositive is also going to be true. So those guys always agree, right? If one is false, then they're both false. The 2 middle ones always agree also. The converse and the inverse have the same truth value. Okay, so if one's true, they're both true. They can't disagree with each other. We're going to write our own. So here we go. So if you live in San Diego, then you live in California. So that's the original conditional statement. That is this, right? That's what we're starting with. That's the conditional statement. So what would the converse look like? Remember, the converse is where you switch the order. So if we switch the order on this, we're going to say if, and remember, it's simply this phrase and this phrase trading places. The word if and the word then don't move. Okay, so if you live in California, then you live in San Diego. And I'm abbreviating here just to get through it a little quicker. Okay, so that's what the converse would look like. Would you guys say that's true or false? So if you live in California, then you live in San Diego. That would be false, right? So I'm going to actually put them over here. I'll put it right here. All right, what would be the counterexample to that? Well, you say, well, I might live in San Clemente, or I might live in Lake Forest, right? So, and I still am in California. So that would be a good counterexample, right? The original, was the original true or false? If you're in San Diego, do you live in California? Yep, that has to be true. It has to be true. Okay, so remember what I set up above. I already know something that's going to take place right now. The converse and the inverse always agree. So if I am going to say that the converse is false, the inverse better be false too. And if this is true, then this must also be true. Those guys always agree. So these two always agree, and these two always agree. They have the same truth value, in other words. So the inverse is now when we put in the word not. So go back to the original statement. So if you do not live in San Diego, and I'm abbreviating, so if you do not live in San Diego, then you do not live in California. Right? And what would you say? Is that true or false? So if I don't live in San Diego, then I don't live in California? No, it's the same counterexample you would have for this, right? I could still live in Lake Forest, and then I would not be living in San Diego, but I still live in California. So you can see how those middle two statements always agree with each other right here, right? And so let's look at the last one. So this is where you do both of these. So, so I'm going to put this first and put in the word not. If I do not live in California, then I do not live in San Diego, right? So would that be true? So if I don't live in California, then I definitely don't live in San Diego, right? So you can see that if that one's true, then this also has to be true. And there we go. So here's one just for you to try on your own. You can pause the video. I'll fill in the answer real quick so you can check it to see if you're right. And that'll be the end of this one. So give this one a try. This is the conditional statement. Okay, that's the original. So you need to fill in the converse, the inverse, and the contrapositive. And then determine their truth value, whether they're true or false. So for the converse, we switch the order. So if it's a square, then it's a rectangle. For the inverse, we would say if it's not a rectangle, then it's not a square. And then for the last one, that's where you do both of these. So if you go back to the original, you have to put this one first and put the word not in there. So if it's not a square, I'm just kind of getting the key